Welcome, grade 5s. Today we revise Natural Science and Technology for grade 5. Welcome to my classroom. I am Sir Rudolph Mathumbu. I am a professional teacher. I hold a degree in education and I am SAYS registered. If you need revision with all CAPS aligned subjects, you are in the right place. Please subscribe for more revisions. If you need private tutoring, please contact me using the contact details provided in the description of this video. Okay, let's get into today's lesson. All right, let's quickly go to section A, question 1. Section A, we will be talking about fuels. So our focus will be mostly on fuels. So, question 1 says, underline the best answer. So this means that it is a multiple choice question. You just underline the best answer. Question number 1 says, energy is stored in. Where do we store energy? Is it stored in water? No. It is stored in rocks? No. Is it stored in the air? No. Is it stored in fuels? Yes, it is stored in fuels. So fuel is the correct answer. All right, we move to question 2. Question 2 says, which of the following is not an everyday fuel? So here the trick is in the word not. So you want something that is not an everyday fuel. Is coal an everyday fuel? Yes. So it is not the right, it's not the correct answer. Is wood an everyday fuel? Yes. So it is not a correct answer. Is petrol an everyday fuel? Yes. So it is not. Then we are left with water. Is water an everyday fuel? No. So this is our correct answer. We have chosen something that is not an everyday fuel. We go to the next question. The next question says, when we burn fuels, so here we burn fuels like coal and wood, we get useful output energy such as, when we burn these two, what do we get? Do we get a sound? No. Do we get cold? No. Do we get light? No. So what do we get? We get heat. So heat is our correct answer. When we burn these fuels, we burn coal, we burn wood, we get heat. Okay, question number 4. Question 4 says, what do fuels need to start and continue burning? What do fuels need to start and continue burning? Do they need water and electricity? No, this is even a bad combination. Do they need oil and sunlight? No. Oil and sunlight will not give you fire. Do they need soil and rocks? No. So what do they need? Do they need heat and air? Oxygen? Yes. So this is a correct answer. This is the correct answer. So we get to question 2. Question 2 says, why is it important to take safety precautions when using fire? Give one reason. Why do we need to take safety precautions when we are using fire? They say we should give one reason. So the answer is that we take precautions to prevent to prevent accidents and harm. So we take precautions to prevent accidents and harm. So we don't injure ourselves, we don't harm ourselves. Question 2. Question 2 says, name one source of energy used in a power station. In a power station, what source of energy do they use there? What source of energy do they use? They use coal. They use coal. Remember, they burn coal to get, I think my coal is, it looks like coat now. Coal. They burn coal to generate electricity. And if you have written water as well, it's still correct. If you have written sunlight as well, you are still correct. So these sources of energy, they are used to generate electricity. Number 3 says, what is the Earth's path around the sun? The path that is used by Earth to rotate around the sun. What is the name of that path? It is called it's orbit. So it's called orbit. Orbit is the Earth's path around the sun. So that is the correct answer. Question 4. Question 4 says, how long does it take? How long does it take? It means they want time for the Earth to travel around the sun once. So for the Earth to travel once around the sun, how long does it take it? It takes it 365 days, which means it takes it 1 year. It takes the Earth 1 year to revolve around the sun. That is the correct answer. So we get to question 3. Question 3 says, underline the best answer. It is similar to question 2. So underline the best answer. What type of energy do we get from burning most fuels? When we burn most fuels, what type of energy do we get? Do we get magnetic energy? No. Do we get sound energy? No. Do we get light energy? No. What do we get? We get heat energy. This is similar to the question that we did in question 1. So, okay, number 2. Number 2 says, how can you prevent, now we want to prevent a fire from happening in your home. How can you prevent a fire from happening in your home? Do you keep all windows open? No. You don't keep windows open when you want to prevent fire. Do you play with matches? No. Playing with matches instead can cause fire. Do you use candles instead of electricity? No, this is dangerous. If you use candles, candles can cause fire easily compared to electricity. Do you store fuel safely and don't leave them near heat? Yes, This is the correct one. You store fuel safely and you don't put them near any heat sources so that they don't burn, and that will not start fire. All right, number 3. Number 3 says, what should you do if you discover a fire in your house? You discover a fire in your house. What should you do? Do you stand and watch? No. Do you call your friends? No. Do you run away as fast as you can? No. What do you do? Alert adults and use a fire extinguisher if available. So this is a correct one. You tell adults, you make them aware that there is a fire, and you use a fire extinguisher if it is available in your home. So question 4. Question 4, number 1 says, what is the Earth's outer layer called? So the layer of the earth, the outer layer of the earth, what is it called? We call it a crust. Crust. So the layer, the outer layer of the earth is called the crust. Number 2 says, name 2 elements. We want just 2 elements that support life on earth. What are those elements that support life on earth? And then the first one is air. Remember that we bring air. So air supports life on earth. Number 2 is water. We drink water. We need water for life. We need water for life. The other one is sunlight. Sunlight as well supports life on earth. Remember that plants, they depend on sunlight for their lives. So if you have written one of these, if you have written 2 of these 3, you are correct. Then question 3. Question 3 says, explain what topsoil is and why is it important. The topsoil, what is topsoil and why is it important? So topsoil is the uppermost layer of soil. So topsoil is the uppermost layer of the soil. The uppermost layer of the soil. So it is important. It is important because it supports plants growth and provide nutrients. So it is important because it supports plants growth. So plants, they grow because they are on the topsoil. Number 4. Number 4 says, list 3 things a fire needs to start and continues burning. Remember when we were doing the fire triangle, we says what causes fire or what is needed for fire. We need fuel, we need heat, and we need oxygen. So 3 things that are needed for fire is fuel, its heat is oxygen. So these are the three things that are needed for fire. We go to question 5 and we do. Question 5 says, match the type of renewable energy source on the left with its description on the right. So this is the name of the renewable energy and how it is described on the right hand side. All right, solar energy. What is solar energy? Is it an energy generated from moving air? No. Is it energy from the heat of the earth core? No. Is it energy from the sun rays? Yes. So the solar energy is the energy from the sun rays. So it means A. Okay, let's just go a bit. It means answer for A is 3. So A is 3. Number 2. Wind energy. What is wind energy? What is wind energy? Is it energy from flowing water? No. Is it energy? Oh, this one is already taken. Is it energy from the heat of the Earth's core? No. Is it energy generated from moving air? Yes, that is correct. So this is the answer. So it means B is 1. B is 1. C. Geothermal energy. Geothermal energy. Is it energy from the heat of the Earth's core? And the answer is yes. This is, when you hear geo, it means earth. So geothermal energy, it is the energy from the heat of the Earth's core. And then what is there? So is C is 2. C is 2. So obvious. What are we left with? We're left with hydropower and we're left with hydropower and energy from flowing water. So that's hydropower. Hydro, remember hydro means water. So hydropower is energy from water. So D is 4. D is 4. So those are the correct answers. Then now we get to section B, and question 1 says, describe 2 safety precautions you should take when using electricity at home. So 2 safety precautions you should take when using electricity at home. Number 1, do not overload a socket. So you don't overload a socket. You don't overload the socket where you are plugging your appliances. You don't overload them. That's a precaution. Number 2, you keep cords away from water. So your electric cords should not be anywhere close to water. You should keep them far away. Then question 2 says, draw a simple diagram. So then we're going to draw here a simple diagram to show how electricity is transferred from a power station to a home. And then you label the key parts. All right. let's start. So this is our power station. You see the chimneys that allow smoke, so we can even put windows there. We generous, we put 3 windows. Our power station should have windows. So this is power station. So this is where the electricity starts, and then now it goes to the transformers. We have got transformers. So these are transformers. So from transformers, the electricity continue to transmission line. We draw transmission line like something like this. Transmission line. Oh dear. So these are the lines where electricity lines, from here they come to the loaner, and then now they continue like this. They get to a substation. So now these lines get to the substation. So this is a substation. And then from substation, the electricity comes out and it gets to it gets to a distribution substation. So this is the distribution substation. So from here, continue and then it gets to the let's use this as our. So they continue. Then they get to. Let's use poles. This should be poles. Yeah, something like this. This should be poles, and they should have their. Oh, my drawing, man, it's so beautiful. And they should have transformers here. You see, this is electric poles. They should have transformers up here. Oh, today my drawing is very, very ugly and disappointing. So from the poles, it goes straight to the houses. So this is home. So this is how the electricity gets to the house. It does not come from the power station straight to home, but it comes from power station. It goes to transformers, and the transformers takes it to the. So the transformers, it takes them through transmission lines. These are transmission line. Transmission line. So they use transmission lines to transmit the electricity to the substation. So from the substation, it comes to the distribution station. Distribution station to the poles. The poles, they have got the transformers. And then from the transformers, it goes straight to your home. So question 3 says, explain load shedding and give 2 ways it affects communities. Explain load shedding and give 2 ways it affects communities. So load shedding is when the electricity supply is intentionally reduced. It's intentionally reduced to prevent power shortage. So it affects communities by causing they cause blackouts, they cause a disruption in daily routines, meaning that your daily routines now are disturbed, and potential economic losses. So, and potential economic losses, those are the effects that load shedding has. So they say explain how stretching an elastic band stores energy and what happens when you release it. So when you stretch an elastic band, you store potential energy when you release it. The energy is converted. The energy is converted into kinetic energy. It's converted into kinetic energy. It converted into kinetic energy. So it causes the band to snap back to its original shape. So you release it, it snaps and gets back to its original shape. So question 5 says describe how sedimentary rock are formed include at least 3 steps of the process. So So here your steps should include breaking down of rocks, and then a deposition of sediments, then compaction and hardening to form a sedimentary rock. So the rocks break down and they deposit sediments and they become compact, and then now the lawn starts hardening the form and they form sedimentary rocks. So section C, imagine you are designing a vehicle for a special mission. Explain how you would use wheels, and axles to make it move more easily. So here we talk about wheels and axles. I would use axles to connect the wheels because axles and wheels reduces friction and make the moving of a car smoother. So you take axles, you connect them in the wheels, so your wheels are connected on your axles and it is easy for them to move. Question 2 says, any way you look at it, South Africa is at the forefront of important fossil finds. There are fascinating sites everywhere. Siyabona, Africa. Discuss the statement, include information about what fossils are as well as their importance, and provide the examples of an important fossil fuels in South Africa. All right. So fossil Fossils are like ancient clues from the past. So they are the remains or marks left by creatures that lived long ago. For fossils come in different forms, such as bones, teeth, shell, or even the prints they made. You usually find fossils in layers of a special rock called sedimentary rock. So they say fossils help us learn about Earth's history and how life has changed over years. Thanks for watching this video up until this point. It shows that you are serious about your education. Remember, if you want to learn something, repetition is the mother of all learning. So it is very important that you keep on repeating this video until you grasp all the concepts that I explained here. If you feel that there are some things that I didn't cover in this video, please do not hesitate to put it in the comment section.